2.2, we're going to talk about polynomial functions of a higher degree. Yesterday we talked about quadratics, we talked about the vertex and the max and min and all that good stuff. We are going to focus on that again. I promise I'll give you guys a quiz review, something to work on. So make sure you are prepared for your quiz next week, the 13th, look, it's on the board. But we have this section, and then we have 2.3, which we're going to break into two parts because our class is going to be shortened tomorrow because of mass. So I'm going to do part of it Friday, part of it Monday, and then kind of wrap it all up on Tuesday and take your quiz on Wednesday. So if we talk about the graph of a polynomial function, what does the word continuous mean? If something is continuous, say it again. Ongoing, okay? There's no break in it. If you notice these two graphs, guys, the one on the right you guys are familiar with because you had to do domain and range and all that good stuff about graphs like that. A polynomial function, when you have high degrees and all this stuff, bunch of x's and that sort of a thing, has what's called a continuous graph. There's no breaks in it. All right, this function over here on the right, this right-hand one over here, this is not a polynomial function. You know it's not a polynomial function because there is a break or a gap. Do you guys see that? So if you're ever asked graphically, does this graph represent a polynomial function? The one on the left, yes, because it's continuous and has nice smooth curves. The one on the right, no. Another feature of a graph of a polynomial function that has only smooth, rounded turns, which is what we just talked about. There's no, like, specific sharp peaks. There's no breaks. There's no... Well, no, that's it, pretty much. If you look at this, we're going to, and I'm going to talk to you guys about the bumps in your polynomial. We're going to talk about the end behaviors of a graph. I know that sounds kind of crazy. What do you think end behaviors of the graph mean? What the graph's doing where? At the ends, okay? We're going to talk about the end behaviors, whether it's where it's going and how it's going, that direction and such. All right, no sharp turns like this. Anybody know what kind of graph this is? It makes a V? Absolute value, good. All right, something that is really important for you guys to kind of just keep in the back of your mind. If you have a polynomial function with a degree of 1, it's a line, correct? You guys agree? What kind of a number is 1? Odd or even? Okay, I just want you to keep this in mind. What do you know about the ends of an odd graph? They go in the same direction or opposite? Opposite, okay, so let's think about this. A positive would go like this, correct? This is a positive. And a negative would go this way, correct? Okay, we know that, that's good. So then I look at this statement here, and it says the function with a degree of 2 makes a what? A parabola, okay, we talked about that yesterday. We have two kind of parabolas, a positive one and a negative one, yeah? We'll talk about left and right in chapter 9. What do you know about the number 2? What kind of a number is that? Even. And what do we know about the directions of the arrows on a graph that's even? It's the same. All right, that is really important information for you guys to hang on to here in a second. Yes, ma'am.
What did you say was the same? Like, what did you say, like, it means even something was the same, but I missed?
The arrows are the direction of the arrows. Okay, good. Good. Whoa, there's a lot of words here. Everybody see this? Blah, 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 blah. What you need to get from this is we're going to talk about functions that have high exponents to the 5th, to the 3rd, to the 6th, something like that. Anything that is an even root, anything that has an even root, even exponent, the graph, the ends of the graph are going to go in the same direction, whether it's both positive, both negative. The amount of bumps inside of your graph depends on the exponent. If you have an x to the 6th, like if you have x to the 6th, and you have to figure out how many bumps, how many turns, if I was gonna graph this, what would it look like? The way that you figure out how many bumps or turns is n minus 1. So in this case, your n is your exponent. So if I had a graph that the highest exponent was x to the 6th, how many bumps or turns would this graph have if you graphed it? It would have 5. Now, why is that helpful? Because you're going to have on WebAssign, you're going to have a question that says match the graph with the polynomial equation. So right away you can say, oh, okay, it's not this one or not this one because I know it should have X amount of turns, X amount of bumps. You're going to be able to tell a lot about a graph just by looking at how many turns it has, the directions of the ends. We're going to talk about all that in a minute. So if I had my highest exponent was negative 3x to the fifth, how many bumps or turns? 4 turns. Good. 4 turns or bumps, however you want to say it. Okay, good. Very good. Okay, we kind of already talked about this, so don't freak out. But it says right here that the graph, when n is even, that's your exponent. When the highest exponent is even, your graph is either going to have arrows going both up or both which way? Both down. The ends. How many bumps and turns in the middle depends upon the highest exponent. But thinking about what the graph will look like, if it's even, the ends of the arrows are both up, both down. If it's odd, whether it's to the fifth, to the third, to the seventh, it's going to resemble an odd function. So it's either going to be 1 up to the right, 1 down to the left, or 1 up to the left, 1 down to the right. What do you think makes the difference there? If it's positive or negative, good. If it's a positive even, both up. If it's a positive odd, 1 up, 1 down, but like with a positive slope of a line. That's why it's really important that you guys understand that. And this is all going to come together in a second, I promise. All right. We're not going to do much with this. I just want to talk about it for a second, about transformations. First of all, ends of the graph. Same direction or opposite directions? All of them are opposite, right? So think about this. This is a negative. So think about the line, a slope of a line, if it's negative. Goes which direction? Goes like this. Good. So your graph is going to go something like that. Don't worry about the shape of it. Cubic makes a little shaky snake, but I just want you to be able to visualize the ends. Look at this next one. Odd again, yeah? Okay, so but is it positive? So it's going to go in which direction? The opposite one. Good. Where on the on the y-axis would this graph move with that +1 at the end? Up 1. Good. Okay, C is positive or negative? Positive, but which direction is this going to move? Right 1. Good. Very good. Okay, good. Okay, now we're going to talk about the end behaviors of the graph, and we're going to do something called the leading coefficient test. All right, there's a lot of math jargon going on here, and what I want you to focus on is what I'm saying. First of all, what is the leading coefficient? Not the highest, the coefficient in the front of the highest. Okay, so what we're going to do is you're going to put your polynomial, you're going to put your poly in standard form. What do I mean by standard form? Say it again. You just want the highest exponent. Good, Alyssa. You want the highest exponent, then in descending order. The leading coefficient, I'm going to call it the LC. The leading coefficient is the number in front of the x with the highest exponent. Now, before you guys freak out, this is a really simple concept, I promise. It just looks difficult. It's harder if it's an odd function. It's easier if it's an even function. Now, what we're going to do is I want you to visually split your graph like this. All right, pretend like the red lines I just drew are an XY. Do you guys agree with me? Because we always read from left to right. Do you agree with me that this is the left side of the graph and this is the right side of the graph? Yep, okay, that's what I'm talking about. Again, over here at the left, here's the right. All right, we're always going to draw ourselves these little pictures, and it's going to make your life easy, I promise. Notice the ends of the graph here and here. On the left-hand side, would you describe the graph as rising or falling? Where's your arrow pointing? Is it rising or is it falling? Okay. On the right-hand side of the graph, what's going on? It's rising. Okay, good. You guys can see that. This over here is negative infinity, correct? This is positive infinity. So you're going to write a statement, and you're going to say, as x approaches negative infinity. You're just like, what? Guys, as you're going to the left, as x approaches negative infinity, what is y, or we'll call it f of x? F of x is doing what? Rising or falling? On the left-hand side of the graph, this is falling. Perfect. So then the other statement is the right-hand side of the graph. As x approaches positive infinity, as x is going to the right, as x's are getting bigger, what is your f of x doing? What is your y value doing? Going up or down? It's rising. It's going up. Okay, perfect. Yes?
Which graph is the first one
We're talking about, we'll call this number 1. Okay?
And we're reading from
Left to right. Always. So now let's look at number 2. We'll call this one number 2. And we're going to compare them. I'm going to say, okay, as x approaches negative infinity. Where am I talking about where x is negative infinity? On the left-hand side or the right-hand side? The left. Negative infinity on x is on the left-hand side. All right, so as x approaches negative infinity, where is my graph going? It's rising. Good, it's the opposite. So you say f of x is rising. And I'll show you a different way you can write it. It's a little easier. And then if I look here, as on the right-hand side of the graph, as x approaches positive infinity, what's going on? It's falling. All right, so now you guys are like, okay, what does this even mean? Which graph is positive? The one on the number 1 or number 2? 1 is positive because think about the direction of a line. If I were to draw a line, that would be a positive line, correct? I'd have the right arrow up, the left arrow down. This is negative. So when you have an odd function, we're going to do these with numbers here in a second, and you're going to be like, oh my gosh, this makes a lot of sense. You use the leading coefficient, the number in front, to tell you, first of all, if it's positive or negative, and then you look at the exponent to say if it's an even or an odd, and then you can tell if the arrows are rising or falling. We're going to do with numbers here in a second. You guys are going to be really good. Hold on. Why is an even function easier? They're both doing the same. So if you have an even function, if your exponent, your highest exponent is even, and it's a positive function, what are both of your arrows doing as you approach negative and positive infinity? Rising. If you have a negative even function, what are both of your arrows doing? Falling. So when I ask you guys, what are the end behaviors of the graph? You're going to tell me rising right, falling left. Rising left, falling right. Doesn't matter. You don't have to write all the x as x approaches and all that stuff. But I'm going to show you how to do it with numbers here, and you guys are going to be like, oh, okay, this is not bad at all. All right, here's an example. We're using the leading coefficient test. Just how we did odd, even, neither, we're going to go in steps. The first thing I'm going to do is say, okay, what is the highest exponent I have? 3. 3 is what kind of a number? Odd. So I'm going to write the word odd and then opposite, because I know that the direction of the arrows are opposite, correct? So now we're going to think about a line. Think about what a line looks like. Positive line versus a negative line. Look at this function. Is this a positive or a negative? So would you agree that it would look something like the ends would look something like this? Obviously, it's not a line, but would you agree they would look something like this? So this is what I think is the best way to do. Put a little x, y in the middle of it. And then we read from left to where? To right. So the end behaviors of this graph, you would tell me the end behaviors are from left to right. What's it doing on the left-hand side? Rising or... Okay, try this again. On the left-hand side of the graph, what's going on? Which direction is my arrow going? Okay, so we're going to say it's rising left and what? Falling right. Thank you. So when we do our leading coefficient test, we first identify the highest exponent. Not necessarily the first, just the highest one. And then you determine if your function is positive or negative, and then you can figure out what the arrows are doing at the ends, right? It's not that bad, I promise. Let's do some practice here. All right, first of all, the highest exponent I see is 12, okay? That's an even number. So I think same. How many bumps? If this were to be graphed, how many bumps would this thing have? 11. Good. So even. So I know that both of my arrows are going in the same direction. They're either both going up or both going where? How do we figure out what they're both doing? That's a negative in leading coefficient. So that means they're both going which direction? Perfect. So it's always easier when it's even. What are my end behaviors? What are we doing on the left? We're falling left. And what? Perfect. Good job, guys. This isn't as scary as it first seemed, right? All right. Highest exponent I see here. 9. What kind of number is 9? 9 is odd, so I think odd and opposite. How many bumps and turns does this thing have? 8. Good. All right, so opposite directions. Is this a positive function or a negative one? Negative. So the ends are going to look like a negative line. So we read from left to right. So I look at the left-hand side and then the right-hand side. What are the end behaviors of this graph? On the left-hand side, we have what? So we're rising left and falling right. Good job. All right, last one. Don't get tricked by this. What's the highest exponent you see? 7. It's not 2. 2's in the front, but that's not the highest. So 7 is what kind of a number? Odd. And then I think odd and opposite. How many bumps does this thing have? I know what you meant. All right, so think about this. Opposite directions. Is this a positive or a negative? It's positive, so it's going to be sloping upwards. I say sloping. I use that term very loosely. It's not really sloping, but we're just trying to figure out what the ends are doing. So on the left-hand side versus the right-hand side, what's happening on the left-hand side? We're falling left and rising right. Perfect. Good job. All right. I think we've seen this before, guys. Zeros of a polynomial function. X equals A is a zero of the function. Look at these words. 0, solution, factor, x-intercept, and I'm going to add 1 to it and say roots. All of those things mean what? Zeros. They mean where the graph crosses the x-axis. How do I algebraically figure that out? You're going to set y, or f of x, however it's written, equal to what? 0, and solve. 90% of the time, what are we going to do? We're going to factor. Factor's never going away. I've never been good at bubble letters. You could have to, yeah. Mm-hmm. Pre-cal honors. Woo, woo. All right, let's go. Let's do this. Find all the real zeros. Yeah. All right, find all the real zeros. So I'm going to say, okay, x cubed minus x squared minus 2x equals 0. What is the first thing we do when we're trying to factor? We look for the, let's say it again, GCF. What's the GCF here? X. I'm going to factor out an x. I'm left with x squared minus x minus 2 equals 0. Guys, that x did not disappear. We just moved it out in front. Now I have a trinomial left, and I say, oh, please, 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 can I factor this so I don't have to use the quadratic formula? Are there factors of -2 that multiply to give me -2 and add to give me -1? X minus 2x plus 1? Perfect. At the beginning, you should look at the highest exponent and say, how many zeros do I have? Guys, how many zeros? How many answers should I have here? 3. How many do I have here? 3. You set everything equal to 0. X equals 0. X minus 2 equals 0. X plus 1 equals 0. Your answers here would be x equals 0, 2, -1. If you want to write them all separately, you can. If they ask you specifically for the x-intercepts, you need to write it as an ordered pair. But if they just ask for the zeros, you can just say x equals. That's fine. We're going to factor. All right, scooting along. Multiplicity. Ay, ay, ay. Multiplicity. What does that word mean? In life, what does multiplicity mean? Multiple, right? I had 2 kids at one time. They were called multiples. Multiplicity is having more than one of the exact same thing. All right, so we're going to talk about the multiplicity of a 0 when you get the same answer twice. Guys, this would occur like on the test the other day. I'm almost done with the test. I haven't done. You guys, this was a question on one of the tests. I went over it yesterday, but x squared equals 0. We take the square root. We get what? X equals 0. But how many times do we have x equals 0? We have it twice. That's called multiplicity. What multiplicity means to us is, it says right here, if k is odd, then the graph crosses the x-axis. If k is even, then it touches and turns or bounces. What that means is if you have an odd number of multiplicity, if you have the same answer once, 3 times, like if you take the cube root, 5 times, then your graph at the x-axis is going to cross through x-axis. Right? Say you get the same answer, you get multiplicity an even number of times, meaning, in the example I just gave you, we had 0 how many times? Twice. Your graph is going to touch and turn at the x-axis, or bounce, you can say it. Let me show you what that means graphically. So I have the answer -2, right? I got x equals -2. And I ended up saying, here, x cubed equals -8. You take the cube root of -8. What's the cube root of -8? What number times itself 3 times gives you -8? -2, okay? So in this case, you guys would have a multiplicity. You'd have -2. So at this point, since you have it 3 times, what's going to happen here? Your graph, it's going to just go through that point. No big deal. Like the other example I had, when we had 0 twice, what your graph is going to do at that point, it's not going to go through the x-axis. What did I say it's going to do? Touch and turn or bounce. So look, it's going to come down here and it's going to go boop and go back up. When you have the multiplicity an even number of times, what's going to happen here to your arrows? Look, they're going to go the same direction. An odd number, they're going to go in opposites. But you'll see, and we'll do more of this, but you'll see action at the x-axis. If it's an even number of multiplicity, it's going to touch and turn or bounce. And if it's an odd number, it's going to go through. All of these things all go together. So we're going to do some questions where we have everything all together. Don't worry about sketching this. I want to talk about end behaviors, zeros, and action at the x-axis. You guys are going to tell me all that stuff. So the first thing I'm going to do is look for what? The highest exponent, okay? Highest exponent is what? 4. What kind of a number is 4? It's even, so I think even and same, right? How many answers should I have for this question? I should have 4 because the highest exponent is 4. Good. So let's talk about our end behaviors. Is this function, this polynomial function, positive or negative? Positive. So what are the end behaviors going to look like? Both of the ends are going which direction? They're both rising. So you would say your end behavior is rising left and rising right. We always go left to right. Perfect. All right, I have to find the zeros. Well, how do you find the zeros of anything? We set perfect. 3x to the 4th minus 4x cubed equals 0. GCF? X cubed, okay. I'm left with 3x minus 4. Perfect. So when I solve this, I have x cubed equals 0. 3x minus 4 equals 0, right? Take the cube root. What's the cube root of 0? Okay, and then over here I have x equals 4/3. Well, I only came out with 2 answers. How many should I have? 4. Correct. How many times did you get 0, guys? This is 3 times, right? Because it was cubed. And then I have 1 time here. I am fine if it says multiplicity. I am totally fine if you guys write the multiplicity like that. You don't have to write me a novel that says the graph has a multiplicity of blah, 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 blah. If you just tell me how many times you have each one, that's totally fine with me. So if you were asked to sketch this graph, okay, so let's just talk about how we would sketch this graph. Think about the end behaviors. What are both of the ends doing? They're rising, so I'm going to put 2 up arrows here. What are my intercepts? Where does this cross the x-axis? At 0 and what? 4/3? Okay. And what does the graph do at both of those places? Is it going to go through or is it going to bounce? What is your multiplicity? Do you have an even number of times you have it or an odd number of times? 3 is odd, so it's going to cross through here and cross through here. So having that in your mind, okay, it's going to, that both of the arrows are going this direction, so just do a quick little sketch. It's going to come here, it's going to go through here, and back through there. Actually, no. Let me do it this way. It's going to come through here, come back up, come back down, and then back up. Because how many turns should this thing have? 4 minus 1 equals 3. Do I have 3 bumps? 1, 2, 3. We're going to work on this. This is the hardest part, is sketching it, but we're going to work on it. You can figure out all sorts of things, what characteristics of your graph, just by finding the multiplicity and the zeros and how many turns and that sort of a thing. We'll do a couple more examples. The last page we're not doing. We moved that last year to a different section. All right, so here's 2. These are very representative of what you might see on a quiz. How many turns, end behavior, zeros, multiplicity, touch and turn, what happens at the x-axis. So we're going to figure all of this stuff out doing very minimal math, computation. First thing I'm going to do is say, what's my highest exponent? 3. What kind of a number is 3? Odd and opposite. Is this a positive or a negative? It's positive. So a positive odd function would look something like this, correct? Okay, here's the left-hand side of the graph, and here's the right. So what are your end behaviors? What's going on the left? It's falling left, great Chris, falling left, rising right, correct? How many turns, how many bumps should this thing have? Yep, 3 minus 1, it's going to have 2 bumps. Perfect. How do we find the zeros? What do? Set it equal to 0, so I'm going to say x cubed plus x squared minus 4x minus 4 equals 0. How many x values should I come out with? Perfect. I have 4 terms. How do I factor this? Group. Awesome. What's the GCF for the first parenthesis? X squared. Great. I'm left with x plus 1. What's the GCF for the second one? Perfect. Take out that negative. So negative 4, I'm left with x plus 1. Yeah? All right. So my new GCF that I'm going to write 1 time out in front is x plus 1. And what happens to my leftovers? They get their own parenthesis. Good. Now, at this point, you can go ahead and solve here. My suggestion would be to fully factor, and I'll show you why in a second. If I fully factor this, this becomes x plus 1. What does x squared minus 4 become? Perfect. X plus 2, x minus 2. So what are your 3 x-intercepts? Where is this going to cross? At x equals negative 1, x equals negative 2, and x equals positive 2. There's your 3. So x equals, you can say negative 2, negative 1, and 2. You do not have to write them in order or anything like that. Now, the reason I say to go ahead and fully factor, if you were, God bless you, if you were to say up here x plus 1 equals 0, God bless you, and then x squared minus 4 equals 0, most of you would get this x equals negative 1, and then what would happen here? A lot of you would say x squared equals 4. You take the square root, you tell me x equals what? 2. It needs to be plus or minus. But again, you could check that you missed that by saying, hey, how many answers was I supposed to get? So that would make me maybe say, oh, I forgot the plus or minus or something. Okay, so let's talk about multiplicity. Do you have any multiplicity here? Do you have any number More than one time. Nope, because -2 and +2 are two different places on a graph, right? So your multiplicity here would be not. You could say one time, that's fine, and one time. If you also wanted to say none, because there is none, you could say that as well. But if you, God bless you, if you just want to say, hey, this is what happens. Now, guys, if you have just every x one time only, what happens at the x-axis? Does it go through it, or does it touch and turn? It crosses through at all three places, right? You could say it crosses through, crosses through, crosses through. Because there's going to be times where it crosses through one but bounces on the other one or something like that. So if you had to draw a picture of this, let's think about all the stuff we just figured out. First of all, what are the ends looking like? What are the ends? What was our end behavior? Falling left and rising right. Just kind of give yourself a little, okay, that's what the end should look like. Where does this graph cross the x-axis? -2, -1, and +2. Okay. What does it do at each one of those points? It's going to cross through. I don't care how high or how low you guys go. It doesn't matter to me. How many bumps should I have in my graph? 2. Okay, so I'm going to go here. I'm going to go, okay, it goes here, comes back down, goes back up. Sure. Did I cross through at each x-intercept? Yes. Do I have 2 turns in my graph? Yes, you guys are good. All right, again, I promise we'll practice this more. All right, last one, and then I'll stop talking. I've been talking a lot, I know. We're going to do the whole thing again. What is the highest exponent you see? 5. What kind of a number is 5? It's odd, so we think odd and opposite. Perfect. Is this a positive polynomial or a negative one? Positive, so it's going to resemble, the ends are going to resemble the end of a line. Remember, we read left to right, so this is my left and this is my right. Let's talk about our end behaviors. God, you guys are so smart. Falling left and rising on the right. Perfect. How many turns should this bad boy have? How'd you get that? Perfect. 5 minus 1 is 4, so 4 bumps, 4 turns. Now we're going to find the zeros. How do we find the zeros? Equal to 0, so 2x to the 5th minus 32x equals 0. GCF. 2x, so I'm left with x squared, x to the 4th, sorry. Minus what? Can I do anything? Can I factor x to the 4th minus 16? So we'll be like, I know I can, I just don't know what. What times what gives me x to the 4th? X squared, good. What times what gives you 16? So minus 4 plus 4? Good. Can I factor a little more? So 2x, then I have what here? X plus 2 and x minus 2. Perfect. Can I factor x squared plus 4 anymore? It's not the difference of perfect squares. They're both perfect squares, I agree, but it's not difference. Now, what do I do with each little piece that I just factored out? Set everything equal to 0. So I'm going to go over here and I'm going to say 2x equals 0. X plus 2 equals 0. X minus 2 equals 0. And then what was the last one? X squared plus 4 equals 0. Okay? Guys, at the very beginning, the highest exponent was 5. How many zeros do we have? 5. Okay, so divide this by 2, and you get x equals 0. Agreed? Yeah. Perfect. Okay, minus 2 here, so x equals negative 2. Plus 2 here, x equals positive 2. Okay, agreed. Solve this. I'm going to subtract 4 from both sides to get x squared equals negative 4. Take the square root. What's x equal? Plus or minus 2. 2i, good. Do I have 5 solutions here? I sure do. How many of them are real? 3. Do you guys see how you have 5 solutions, but you only have 3 real ones? So how many times is this graph actually going to cross the x-axis? 3 times. The imaginary ones, they count in the saying how many zeros there are, but you can't graph imaginary on a normal xy plane. Do you guys have any multiplicity? No multiplicity. You have every single answer how many times? Once. If you had one answer 3 times, you'd have multiplicity of 3 times. But since you have all of them just one time, one's an odd number, so then there's no multiplicity. Yeah. No, because one's positive, one's negative. You know what? That's a good thing. Maybe this can be confusing when you guys write the plus and minus. Write it out separately so you see that positive 2 and negative 2 are different. They're different places in space. It's different places on a graph. So if you were going to graph this, you would use the end behaviors. You would say, okay, what are my arrows doing? Down, left, up, right. It would cross at negative 2, 0, and 2. Yeah? Okay, good. What is it going to do at these 3 points on the x-axis? It's going to cross through. How come it's going to cross through? Because you only have it one time. If you have them an even number of times, it's going to bounce. If you have them an odd number of times, it's going to. This, my daughters were writing something. This, guys, we're going to do, we moved it to another place in the chapter, so we're not going to do that. All right, so you guys have a web assignment. It's like 15 questions, something like that. It is not due until Monday. We are moving on to the next section tomorrow, but just to give you guys a little bit of time to work on this. Guys, please do not email me and say WebAssign keeps marking my answers wrong. Figure out the reason why it's marking them wrong, right?